Okay, in this video, we're going to talk about equation solving and modeling. So we have some vocabulary. So the first thing is we are going to use the order of magnitude. So use the order of magnitude. To compare any like quantities. The Richter scale model is going to be R equals log A over T and then plus B. And it measures the magnitude R of an earthquake. A is the amplitude in micrometers of the vertical ground motion at receiving station. T is the period of the seismic wave in seconds, and B is the dampening of the seismic wave as the distance of the epicenter increases. Now your pH scale, you're going to have pH is going to be equal to negative log of H, the positive, and that's going to be a scale that measures how acidic or basic a substance ranks. And so the scale ranges from 0 to 14, where 7 represents neutral, and each whole pH value below 7 is 10 times more acidic than the next higher value. And then Newton's law of cooling, that's going to be T at T is equal to T sub M plus T sub 0 minus T sub M, and then times e to the negative k times t. So here's some formulas that do use your logarithms, and so we're going to implement those in with some of these modelings that we're going to see. We're also going to be solving some equations, and in order to solve equations, when you get things that look like this, you get your equation down to some base raised to an exponent equal to that same base raised to a different exponent, then your exponents must be equal to each other. And so that'll set up some kind of equation that you'll use to solve. And the same is true over here. You get two logarithms that are equal to each other. They have the same base. Then again, these arguments must be equal to each other. All right, so for example 1, we're going to be solving this equation, and notice that our exponent is up in here. That's where our variable's at. So in order to solve this, the first thing we're going to try to do is get that variable by itself. So I'm going to move 24 over. And so that's going to give me 1/2 raised to the x over 3 equals, well, 6 over 24 is 1/4. And so I can't change 1/2 to 1/4 without increasing its value or changing the value. However, I can take 1/2 and bring that down, but then say, well, really 1/4 is 1/2 squared. Now I can do that, and I didn't change the value of the term, I just changed the appearance of the term. And now this is just like what we just talked about, where these bases are the same. So these exponents here must be equal to each other. So I'm going to have x over 3 has to equal 2. And to solve that, remember, you'd have a proportion. You'd put 2 over 1. Cross multiply, and you get 2 equals 6. And so x equals 6 should be your final answer. All right, so to solve our next equation, this is going to be something terrible here, because you're dealing with e. You're going to have to incorporate natural logarithm to both sides. So we're going to say natural log of e to the x, and you would always go to natural log if e is involved. Natural log of x raised to the, or not x, sorry, natural log of pi raised to the 1 plus x. Well, we know that natural log of e raised to the x all simplifies down to just x, so that was nice, equals, and then we're going to move down this exponent, so that's going to be 1 plus x times natural log of pi. Now we're still solving for x, so we're going to have to distribute this into each part. So we're going to have natural log of pi plus x natural log of pi. And since this term has x in it, I'm going to move it over to the other side. So I have x minus x natural log pi equals natural log pi. Now I'm going to factor out an x, and that's going to leave me with 1 minus natural log pi equals natural log pi. Now I'm going to divide by 1 minus natural log pi. So those cancel. So x equals natural log pi over 1 minus natural log pi. So that one's kind of a tough problem there. So again, we started out, we had to involve natural log, and that's so that we can move our exponents down, and natural log of e to the x is just x. And then we had to solve for x, which meant that x inside parentheses, we had to do our distributive property. And then after that, we had this x over here, so we had to move it over with our other x. Then we had like terms here and here, we had those x's, so we could factor those out. And then we had our 1 minus natural log pi that we could divide over. So a lot of algebra there. All right, now the next part, we're going to, I don't know about support our answer graphically, but we're going to go through and we're going to factor this, and we're going to see if we can't get our answer for it. So for the first part, let's see if we can't factor this. And if you're not sure about the factoring part, think about this as x squared minus 3x minus 4. If you want to think of it that way first. So then that's going to give you x minus 4 times x plus 1. And then you would say x equals 4. And then x equals negative 1. But we didn't really have x. We had e, didn't we? So we're going to bring back down our e and say, well, really that's e to the x is 4. And e to the x is negative 1. Well, the first thing is e to the x can't ever be equal to negative 1. That's outside the domain. Remember, e to the x, its graph would look like something like this. And it doesn't ever go past that negative 1 over there. So here, that's not going to work for us. So that gets tossed out. And then over on this other side, with here e to the x, how do we get that x to move down? Well, that's where we go back and grab our natural log of both sides. We move that x down. or you can say natural log of e to the x is just x, equals natural log 4. And that's your answer, natural log of 4. All right, and so for our next problem, very similar. We are going to take 2 and multiply that over here. So we have e to the x minus e to the negative x equals 16. And then that e to the negative x, we don't like that. So we're going to multiply everything by e to the positive x to get rid of it. So that's going to be e to the 2x, because when you're multiplying with like bases, add your exponents, minus e to the 0 equals 16e to the x. So when we rearrange all of this, we get e to the 2x minus 16 e to the x, and then minus 1 equals 0. So this won't factor. So what we can do is go through our quadratic formula, negative b plus or minus the square root, b squared minus 4ac, all over 2a. Okay, so we're going to say e to the x equals, so we're going to have 16, because it's negative b, but 16 is negative, so it's going to be 16 plus or minus the square root, b squared, so that's going to be 256, minus 4 times a times c. So that's really just going to be a positive 4. And that's all over 2. Okay, so we can use our calculators to simplify that up some, but I don't have a calculator with me, so I'm going to leave it like that, and then y'all can go ahead and simplify that as you go. All right. Now looking at our next problem, example 5. This one, we're going to use some of our rules here. Notice we're separated with a plus sign. So we're going to put that back together and say natural log. That's going to be 3x minus 2 times x minus 1. And that's going to be equal to natural log of x squared, because we moved that up. So now we can pretty much, we'll cancel out those natural logs, and we're just going to deal with the algebra. And we'll have to FOIL this out, so we're going to have 3x squared, and then we're going to have negative 3x minus 2x, so that's minus 5x. And then we're going to have plus 2, and that's all equal to x squared. So when we move that over, we're going to have 2x squared minus 5x plus 2 equals 0. And then that's going to factor into 2x minus 1, and then x minus 2. So then we're going to have x equals a half, and then, or x can be 2. All right, and so let's look at the next one. We're going to have log base 3, and we're going to have x times x minus 8, and that's going to be equal to 2. Now this one we're going to have to go back to our power form, we're going to take 3, raise it to the second power. So we're going to say 3 to the second power is equal to all of this over here, x times x minus 8. So that's going to be 9 equals x squared minus 8x. So move your 9 over so you can factor. So that's x squared minus 8x minus 9. And that's going to factor into x minus 9 times x plus 1. And so you get x equals 9 and x equals negative 1. And we'll have to throw out the negative 1 because when I put a negative up here, that's going to put a negative. It's the argument of a logarithm, and that's outside the domain of the logarithm. So that's not going to work. All right, so let's look at the orders of magnitude and logarithmic models. So in our calculators, whenever we go through and do these, with your calculator, you should get 1.477, 2.447, the next one, 3.447. I'm seeing a pattern here, comma, 1, 2, 3, and then 10.477. So we see a little bit of a pattern. And in question 2, it asks, what is the pattern of the integer parts of the numbers? And notice it's really just 1, 2, 3, all the way up to 10. What is the pattern of the decimal parts? Well, that's really just 0.477, isn't it? So how many orders of magnitude is greater than 3 times 10 to the 10th than 3 times 10? Well, that's going to be 10 minus 1, isn't it? Because there's an understood exponent here. So you're just going to say 10 minus 1, so it's going to be 9. Okay, example 7. How many times more severe was the 2001 earthquake in India than the 1999 earthquake in Greece? And it gave us our 2 Richter scale readings. And so we're going to say R1 minus R2. And so we're going to look at our 2 logarithms. So I'm going to look at our formulas. So that's going to say log A1 over T then plus B. And then that's going to be minus log A2 over T plus B. Right? And notice our B's will cancel each other out. And so our R1 reading was 7.9. We're getting that from the problem. Minus our 7.2 reading was 5.9. And that's equal to log A sub 1 of T minus log A sub 2 of T. So when we subtract these, we get 2 equals, and then remember your logarithm properties. You can put these together, and so that's going to be log A sub 1 over T over A sub 2 over T. And let's simplify that fraction over here. Those T's will cancel. So that's log A sub 1 over A sub 2. this is base 10, so we're going to raise it to the second power. So 10 squared is going to be equal to a sub 1 over a sub 2. And so what this is telling me is that India was, and it's 10 squared or 100 times, greater than Greece. Okay, so now we're going to look at the vinegar. So what is their hydrogen ion concentrations? So for vinegar, you're going to have 2.4. So from here, you have 2.4 equals negative log H. And so you're going to say 10 raised to the 2.4 equals, right? And so from that, we're going to get 3.98 times 10 to the negative 3 moles per liter. Okay, for soda, you're going to have 8.4 equals negative log H. And so you have 10 to the negative 8.4 equals positive. So again, 3.98 times 10 to the negative 9. All right, how many times greater is the hydrogen ion concentration in the vinegar than the baking soda? So you're looking at your exponents there. So you had vinegar to the soda is 10 raised to the negative 2.4 compared to 10 raised to the negative 8.4. So that's about 10 to the 6th. Okay, so how many orders of magnitude do the concentrations differ? And that's going to be 6. All right, and lastly, with applying Newton's law, I think we're going to stop on this one here. We're going to stop here.